Hi and Assalamualaikum to Dr. Musab and fellow audiences. We are from Group 2. We'll be presenting the results from our consequence analysis project as part of our safety and risk assessment assignment. I myself, Muhammad Arif, will be joined by my group mates, NASSER KHALED, HASSAN Majid and ABDULLAH. These are the contents for this presentation. In the introduction, I'll be talking about the overview of the project and some background of the chosen facility alongside with the MSDS, Material Safety Datasheet. NASSER will then continue with the results for Accident 1, flammable gas leakage of a pipe, followed by Accident 2, an explosion by a boiling liquid expelling vapor by AMMAR, and Accident 3, jet fire caused by leakage of methane by HASSAN. Moving to introduction, this project's workflow is as follows. We chose an industry facility residing in Malaysia and then did several possible scenarios of release. Simulations were then done using Aloha software to analyze the consequence and risk for each type of release. And lastly, recommendations were suggested to prevent or mitigate the release. For our project, the chosen industrial facility is Port Dickson Refinery owned by Petron Malaysia, situated in Port Dickson, Negeri Sembilan. And a little bit of its background. The refining facility was established in 1963 and it provides the Malaysian market with a sustainable supply of petroleum and gas products. The facility is convenient because it is connected to cities via a strong network of transportation routes, enabling efficient and safe distribution of Petron's premium products. The refinery has a crude distillation capacity of 88,000 barrels per day. It also houses a number of processing units, including distillation unit, reformer, steam generator, and storage. Its products include gasoline, jet fuel, diesel, LPG, and low sulfur waxy residue, or also known as LSWR. Raw materials include crude oil and condensate. In order to analyze the risk involved, we will refer to the material safety sheet for each of the product. Only a portion of the data from MSDS is shown in the next slide. For crude oil, it is extremely flammable, both in liquid and vapor state. It causes serious eye irritation and may be fatal if swallowed or enters the airways. As for gasoline, it may cause genetic defects and damage to organs through prolonged or repeated exposure. Jet fuel has similar risks involved as the crude oil that are flammable liquid and vapor. It causes skin irritation and may be fatal. For diesel, it can cause drowsiness or dizziness, as well as cancer. It is also toxic to aquatic life. LPG is extremely flammable gas, and if contained under pressure, it may explode when heated. For low sulfur waxy, the risks are harmful if inhaled and suspected of damaging fertility of the unborn child. Next, I'll pass to Nasir to talk about the results.
Hello. So for the results and discussion, for this project, we set 3 accidents possible to happen in this facility. The first accident is a flammable gas leakage of a pipe, and the second one is an explosion by a boiling liquid expanding vapor, and the third one is a jet fire caused by a leakage of methane. So during the designing of these 3 accidents, we try to diversify the data input, especially for the weather conditions and the type of chemicals causing the accident and the type of accident in the first place. So after designing the input, we use the Aloha simulation to simulate the Aloha software to simulate each of the accidents. So moving on to the accident number 1, the flammable gas leakage of a pipe. The accident input for this accident, we set the date and time to be in 28th of May 2020, 7:11 a.m. And the chemical would be propane as replacement for the LPG, since Aloha does not simulate solutions and only simulate pure chemicals. For the weather, we set it up to be cloudy and 26 degrees Celsius. The relative humidity 75% and a wind speed of 106.7 miles per hour coming from the southeast. For the pipe specifications, we chose to be a smooth and 300 meters long pipe with a diameter of 3 inches and an ambient temperature of 26 degrees Celsius and 2.3 atm of temperature. And the gas escaping from this pipe would be escaping from a hole with an area of 7.07 square inches. The type of output that we got from the ALOHA software are two types: the wordy output and the graphical output. So for this type of output, we got that this accident will cause a flame that is 10 meters long, and the burn duration will be 1 hour, since we didn't set up any like time limit. So the ALOHA software set it up to be for 1 hour maximum, and for a burn rate to be 96.4 kilograms per minute, and a total amount of 2,802 kilograms of this chemical propane that would be burned during the 1 hour time. So in this picture, you can see this red zone and the yellow zone. This is the graphical output simulated into the map of the facility. So, and here, this is the thermal output, the graphical output, sorry. This is the thermal radiation threat zone, and it has 3 zones for the accident that will be caused by the accident: the red zone and the orange zone, and also the yellow zone. The orange zone is so tiny that only appears if we close up to the graph. So you can see this is the red zone and this is the yellow zone, and this is only the orange zone. So for the red zone, it will have a diameter of 10 meters and will be potentially lethal, and the orange zone would be 10 meters as well. We assumed it to be 10 meters diameter, and with people there will have a 2nd degree burns. And for the yellow zone, it will have a diameter of 19 meters, and people inside this area will have possible pain. So you can see here the accident only affect a zone of 19 meters only, and that is why the simulation here, or the graphical map, only appears like so tiny. So for this type of accidents, we set up some recommendations to mitigate them. So the first one is that pipelines should be constructed and manufactured and maintained regularly to ensure the safety of the employees and any third parties involved in this type of accidents, particularly against any risk of fire and explosion. And also, the pipeline should be equipped with practical and effective facilities for safe operation, like level controllers, pressure controllers, alarms, and valves. And also, the pipeline operator should have drawn up and implement internal emergency plan to ensure that and ensure that these are reviewed and tested and revised regularly. Also, to mitigate any possible external corrosion of any pipe, the underground pipeline should have protected with a suitable coating and cathodic corrosion protection, and the above ground pipe should have a suitable paint layer or coating around them. And finally, the plant should provide a restoration plan and a cleanup plan of the environment after any accident that might happen, regardless any possibilities. So this is all for the accident number 1, and we will move to accident number 2, and AMMAR will be presented.
Okay, thanks, Nasser. So now let me move to the second scenario, which is an explosion by a boiling liquid expanding vapor. There was a boiling liquid expanding vapor explosion of flammable liquid, which is benzene, in one of the spherical tanks of the facility. The explosion destroyed the facility completely, with an impact reached to around 800 meters from the facility. So from the data that we collect, which related to the weather on the day of explosion, also the characteristics of the benzene itself, as well as the parameters of the tank, we simulate the condition in ALOHA software, and we got these results. The results was classified into 3 regions depending on the effect during the 60 seconds from the explosion. So the first region is considered to be red region, which has which is measured to be around 348 meters from the facility. So in this region has potential of lethality. Okay, the second region is which is the orange region. It is measured to be around 493 meters from the facility. This region is considered to be a second degree of burn region, and also the third region, which is the yellow region, which is measured to be around 769 meters from the facility. This region has only a pain effect. So these are the results that we have got from simulating our data in the AL-OHA software. So now let me move to the recommendations to mitigate the incident. Actually, there are some recommendation also to prevent this accident from happening, like having an alarm that can help when the temperature exceed the limits. But since the accident has already happened, so I just will talk about the recommendation that can mitigate the accident. So the first thing is that we have to use PPE, as we know that PPE can isolate the whole body from any possible dangers. So this is very important to take in consideration. The second thing is that we have to evacuate the zone that may be affected by the accident as fast as possible. And the third thing that we have to be careful about is that we have to have firefighters who can control the fire in a short period of time. So that is about the second scenario. Now let me move the presentation to Hassan.
So hello and assalamu alaikum. My name is Hassan Majd ABOUZAID. My metric number is 199506, and I'm here presenting about accident 3 for safety class. So the accident is about a leak from a hole in a horizontal cylindrical tank. So first of all, for the accident input. So the date and time for the accident was on 6th July 2011 at 9 a.m. morning and 8 minutes. The weather of that day, it was windy with a 37 Fahrenheit, and the humidity was 5%. The wind rate was 5 miles per hour northeast. So the chemical was burned and get out leaked was methane, and it's leaked from a tank specification that get a diameter of 1 meter and length of 9 meters, and its volume is 7.07 meters cubic meters. The circular diameter was opening diameter of 0.5 meters. So second, for the data output, the flame length was 229 meters and the burn duration was 20 seconds with a burn rate of 116,000 kilogram per second with a total amount burned of 90,718 kilograms. So for the thermal radiation threat zone, so first of all, for the first zone, which is 428 meters from the place of the fire, is considered as a red zone with a potential of length during 60 seconds. And for the second zone, the zone which is 670 meters from the place of the fire is considered as an orange zone, which can be classified as a second degree burns with 60 seconds. And third is the third zone, which is 971 meters from the place of the fire, is considered as a yellow zone, which will have a pain within 60 seconds also. So for recommendation and mitigating, first of all we will start with recommendation. So having an alarm system that can check if there is a leaking that automatically shut off the system is a good idea to pretend that kind of accident, and also figure out the problem before it happens by asking the person on duty to check the control device regularly. And for mitigating, there are several things to be measured for mitigating steps when having such this incident. So first of all is to use PPE. Second is analyze and capitalize and hazards. Third is have a plan to evacuate the zone that may be affected by the accident. Fourth is the emergency response procedure, which can be planned to control the fire in a short period of time. For example, nearby firefighter cars or firefighting systems that can be designed on the plant. So this is the end of my part, and thank you.
In conclusion, all three scenarios were analyzed and the results were obtained from simulation using Aloha and MOHAMMED software. During the duration of this project, the team gained valuable knowledge, especially in the field of chemicals plant safety. And here are the resources that made this project possible. And lastly, thank you for watching. And a special thanks to Dr. Musab, our lecturer for safety and risk assessment course, and also to our fellow groupmate. Until then, see ya.